Hello, my name is Helmut Erler. Today I will show you how I set up a Reaper project with SimuLathe Cut version for a fixed pitch cutting system. I will start from scratch and walk through the entire process. We will build the signal chain step by step, calibrate the system and make sure that everything behaves predictably from record to analog to digital and back. The goal is to establish a reliable and repeatable setup. All further processing and cutting decisions then will be based on a known reference and can be stored with the project for total recall. We will use only the minimum amount of tracks and meters necessary for setup. Later, we can use some convenient extras, but for now, we keep it simple. Let us dive right into it. 1. Creating the input pickup track. This track is used to receive the signal from the turntable. Connect the line output cable of your turntable or phono preamp to an analog line input of your sound card. Create a track and name it Pickup. Set the corresponding input, enable record. Now you can hear the signal from your turntable. Fine. Play a 1 kHz test tone from a test record. It should read -20 dBFS. Most likely, you will have to adjust analog levels to achieve this. Some phono preamps have adjustable output gain. Most sound cards have adjustable input gain. You can also use a digital gain stage first in the track, especially for fine tuning. To make measurement easier, insert a band pass EQ to filter out rumble, distortion and unwanted noise. Focus only on the 1 kHz tone. Add a meter after the EQ and fine-tune level until it consistently reads -20 dBFS. 2. Creating the disc mastering track. Next, create another track and name it SimuLathe. This track will host your disc mastering console. Insert SimuLathe Cut plugin. You can use the demo. It's fully functional with no time limit. But be aware that the settings are not stored in demo mode. Change the SimuLathe configuration as follows. Reference level -20 dBFS. Minimal groove width 0 micrometers. Preview to minimum. Input gain trim -20 dB equal auto gain off. This will be the heart of your cutting system. You will play all audio for the cut through this track. Processing, metering and setting the cutting level will all be done here. From now on, since we changed the calibration, do not use any factory presets in SimuLathe anymore. In the following videos, I will explain how to set the filters and processes in detail. For now, you can dial in these values and call it a day. 3. Routing the audio from the disc mastering console. In Reaper, from the Effects window, right-click on SimuLathe and build a multi-channel routing to send each of the outputs to a separate track: monitor, mod, and preview. Monitor is used to listen to the output of SimuLathe. Mod stands for modulation. In disc mastering, this is the signal chain that drives the cutting stylus and modulates the groove. The preview track is not used for a fixed pitch system. We delete it. In software that does not support multiple outputs of audio processors, such as Ableton Live, you will have to do the routing slightly different. For example, via a bus or return track routed to an external out. You will find workarounds. The mod track sends audio to the cutting amp. It must not go to the master bus, but to a separate output of your sound card, connected only to the cutting amp. Right-click on the root box to make the output adjustments here. Enable solo defeat on this track so it stays active, even when other tracks are soloed. This ensures that your cut is never interrupted. Insert a -10 dB gain stage at the beginning of the plugin chain. We need it to provide digital headroom for the RIAA encoder and the head compensation EQ that will come later. 4. Signal flow overview. SimuLathe sends its modulation signal to the mod track, which goes to an external output of your sound card and then to the cutting amplifier and cutter head. It also sends its monitor signal to the monitor track, routed to the master bus for listening. The signal from the turntable feeds the pickup track, which is also routed to the master bus for monitoring. In this minimal setup, all monitoring and listening is done through the master bus, soloing the source that you want to hear. 5. Calibration procedure. To calibrate the system, we will play a 1 kHz tone of our digital reference level into the cutting system and adjust analog gain of the cutting amp until the pickup reads -20 dBFS, just like it did with the test tone from the test record. This is step by step. Switch off the cutting amp for safety. Play a 0 dBFS 1 kHz tone into SimuLathe. The input gain trim sets the level to our -20 dBFS reference and the meter reads 0 ppm cut. Now, just to make sure everything is as it should be, play a little with the disc cut gain. Meters should follow and you should hear the level change. Double-click the gain potty to reset to unity again. Turn the analog gain of the cutting amp all the way down, switch on the amp and start cutting. Solo the pickup track for monitoring and place the pickup in the groove that you just cut. Raise the analog gain of the cutting amp gently until you read -20 dBFS in the pickup track meter. Be careful, there is a delay between what you do at the amp and what you get from the pickup. You can gently tap on the machine and observe how long it takes until you can hear it in the pickup. The delay should be something like 1 second. If the delay is longer, you're not reading the groove that you've just cut, but something down the line. Advance with the pickup until you read immediately after the cut. With the gain, make small, stepped increments. Watch until they appear on the pickup and repeat until you read -20 dBFS in the pickup. Go step by step. Wait until you see something before you go ahead. Take your time. If you run out of gain on the amp, you may need to change the input sensitivity selector switch at the back of the unit. It might be difficult to nail it exactly to -20 dBFS, but you should be close in a range of ±1 dB. You can also use a digital gain stage for fine tuning. This ensures a fully calibrated loop: digital, analog, record, analog, and digital again. Now the basic calibration is done. Don't change the gain on your cutting amp and your sound card anymore. Switch off the cutting amp now to prevent your cutter head from damage. Because next we will insert the RIAA encoder and the cutter head compensation EQ in the effects chain of the mod track. Before we can cut anything else but a 1 kHz tone, this must be done. We will make sure that the 1 kHz tone passes these steps with no level change. And we will evaluate how pink noise will react to these steps and how much headroom is available. Insert a meter in the mod track last and play the 1 kHz again. It must read 30 dBFS, our reference level, after the -10 dB headroom gain stage. Now insert the RIAA encoder and place it before the meter. You should read -30 dBFS. If not, adjust the output gain of your RIAA encoder until you see no boost and no cut at this frequency. RIAA curve is flat at 1 kHz. Now insert your compensation EQ for the cutter head and place it before the meter too. Again, no cut or boost at 1 kHz should happen. If it does, adjust the output of the compensation EQ until 1 kHz is at -30 dBFS again. Now, bypass the RIAA encoder and compensation EQ for the cutter head and play pink noise. You should read close to -30 dBFS also. As this is a random signal, the reading will be a bit fluctuating. This is fine. Next, engage RIAA encoding. The level of the pink noise raises to about -26 dBFS because of the high frequency boost. Fine. Now engage the head compensation EQ too. Level will most likely raise again. In my case, the level rises significantly to about -17 dBFS because my EQ compensation curve boosts the high frequencies very much. It might be slightly different for your EQ, but somewhere near. So, the digital level after encoding is, depending on frequency distribution of the sound, louder than the incoming signal, but still has sufficient headroom. Now it's time to look at some music. This kind of music in the real world is not cut at reference level. It is typically cut 10 to 12 dB louder. When we apply this level at the disc cut gain of SimuLathe, we now see peaks of roughly -7 dBFS at the output of the motor track. This is fine. With this gain staging, we avoid clipping, the digital system remains clean even at higher cutting levels and with strong EQ compensation for the cutter head. However, be careful with such loud cutting levels and high frequency boost. You might, depending on the input material, produce very high current to the cutter head and blow the fuses. With this calibration in place, we now have a stable and predictable cutting system. This allows us to use the groove model of SimuLathe to shape level, spacing, and behavior of the cut in a controlled and meaningful way. In the next videos, we will build on this foundation and explore how to use these tools to optimize real program material and get the most out of your cutting system. That's all for now. Thank you. Goodbye.